going to talk about what we just learned from our discovery activities. So hopefully it will help guide us, and I promise our notes, we've got a good amount of vocab to go through, but then after that, it's really just kind of working with this function. So you guys saw a lot in that little Desmos discovery activity there. Who can tell me if I change the number out front? So let's talk about my A value. If A is negative, what happened to my function?
It was above the x-axis. It was below the x-axis.
It was below the x-axis. So as I walked around, I saw some people wrote down that it flipped over. So kind of the fancy math term that we use, if A is negative, it reflects over x-axis. And it's okay if you wrote down some of those other terms like flipped, right? I'm going to teach you, even if you haven't learned it last year in geometry, right, some of these fancier terms that we give about transformations. All right, what was the other thing we noticed about A? What did that number 2 that we had out front, how did that make it? What did that do to my parabola? Look at the discovery activity when we changed it from 1/2 to 2. How did that change my parabola?
It moved over.
No?
Oh, wait.
So look when we had it at 1/2 and then we had it at 2. How did that change your parabola? I think it was
the width. Like that.
Yes, it would even change it how wide or skinny it was, right? In our math terms, we're going to call that a dilation or a compression.
What do you want us writing these?
I want you writing these at the bottom of the worksheet that we just did where it says, what do the A, H, and K do? That's where I want you writing these. All right, our next one, the H, meaning the number inside the parentheses. What did that have me do?
It moved it over 1 on the x-axis, -1 on the x-axis.
We moved right and left. We call that a translation, and it is the opposite of what you think. Meaning, if you have a minus sign in here, so if this is -1, you go to the right. If it's a +1, you go to the left. So in that case, it's kind of the opposite of what we would think along the x-axis. Last but not least, the K. What did the K? If I had tacked on a number at the very end?
It makes it go up or down on the y-axis.
Up or down, perfect. And it's exactly what you think. So it's also a translation and exactly what you think. So it's not the opposite. What it means is if you have a positive at the end, you go up. If you have a negative at the end, you go down. So ultimately, this is the summary of what I wanted us to learn today. Now we're going to write it down in our notes and just formalize it out, right? We're going to define what translation means and define what dilation means and all that stuff. So that's why the first half of your notes today is just going through the vocabulary. But I'm hoping this at least gives you a little bit of context, a little bit of background. That's why we do kind of discovery activities, is so that instead of you just learning from me, I'm hoping you were able to see this yourself on Desmos. So keep that discovery activity. The notes that you took on A, H, and K will only help you as you do your homework. I know I don't usually throw an extra little note thing in, but this was one. I should have just had it in our note packet to begin with. Questions? All right. So we're going to skip over the warm-up because I think we've done a good amount of practice with 3.3 with all of that work. And let's get right into our vocabulary, which is to define some of these things. And I typed them out because I'm recording the lecture, and so I wanted to make sure that everybody watching the recording would be able to read it, not necessarily my handwriting. So the technical term for transformation, it is to change. But when we talk about it in math, we say to change the graph of a function in size, shape, or orientation. A reflection is to mirror the image over a line. And what I do is I put a negative sign. If I have a negative at the very beginning of my function, that tells me to reflect over the x-axis.
What page is this?
3.4.
It's on page 12.
Thank you. Page 12. We skipped over the warm-up. So on your discovery activity, bless you, on your discovery activity, we did y equals x squared, right? We started with a parabola. I wanted us to have a second example, so in our notes, we're going to be doing everything based off of y equals x. It's going to follow the exact same principle. I just wanted you to see that regardless of what function we're studying, the rules are the same. If it's in the parenthesis, it moves it left, right. If it's outside the parenthesis, it moves it up, down. It does not matter what function you're looking at. These rules will apply to all of them. All right. After reflection, we have what we call a scale change or a dilation. So this is when we look for a coefficient, a number in front of our x. If we have a big number, whether it's a big positive number or a big negative number, right? We saw 2, we could put in 3, 4, anything like that. When we have a number that's greater than 1 or less than -1, the function is going to get steeper. We're going to stretch it out. We're going to get further away from the x-axis. Our example that we have is if I have y equals 3x instead of y equals x, I have a scale change by a factor of 3, or I've stretched it out to now have a slope of 3, whereas before it had a slope of 1. So the other half of the scale change, as we just talked about the stretch or the dilation, the other one is called a compression. So a shrink. If I have a number that's in between -1 and 1, so say I have a number like -1/2 or 1/3, any kind of number that falls between a -1 and a +1, it means my function gets flatter, it gets compressed, it gets pushed down so it's closer to the x-axis. So if I started with y equals x, right, remember we're always starting with y equals x, and now I change it to y equals 1/2 x, right, my line isn't as steep anymore. I have a smaller slope. You guys are doing a great job writing down all this vocab. I know it's a lot. Now our very last new vocab word, no, I did not spell it wrong. It is called a translation. Oh, let me grab my here. So a translation is a slide. It could be left, it could be right, it could be up, it could be down. It's a movement of my original function. It's not going to change anything about its size or its shape, right? Our parabola will still stay kind of the same width. But if I have my function here and this +2, this tells me to translate left 2. That's what this part tells me to do. And then my red part out here, that tells me to translate down 6. All right, so that's it for vocab. I know that was a lot of vocab, but I sometimes think if you guys copy it down, it hopefully helps it sink in. So now on the back, we have a number of different types of examples, and I'm pretty sure we'll be able to speed through most of these. Now I do apologize because in your notes, right, everything is black and white, whereas up here on my screen, I do have some colors. So let's pretend that we're starting with the black function, and then it's ending up as the pink function. So in my first one, which I did for you, I have a translation 2 to the right. Now let's look at this next one. I started out with the black one, and then I kind of pushed it into the x-axis. So what I did is I compressed it. Now when you talk about either a stretch or a compress, you have to say by what amount. So here's my recommendation. Find a point. I'm going to pick this one up right here. What is the y value of this point? 2. It went to here. What is the y value of that point?
1.
What did I have to multiply by to go from 2 to 1? A half. I had to multiply by 1/2 because I'm going the other way, right? I'm going from the black to the pink. If I was going from the pink to the black, yes, I would be multiplying by 1/2. All right, this next one, we've got too many. Let's just kind of erase this first one, this top one. I'm going from the black to the pink. What did I do? I went down. So, see, you guys are already seeing it. All I'm going to do is add the fancy term. Translate down, was it 1, 2, 3? 3. So don't doubt yourself. A lot of the stuff in this unit, and even in this section, is kind of the common sense stuff you've seen before. So trust your gut. It's probably right. All right, look at this one. I went from the black to the pink. This time, instead of compressing it down, I stretched it. And how many did I stretch it by? What was my factor? What did I multiply by? 2, correct. Right? The y value here is 2, and now the y value is 4. So I had to multiply by 2. Perfect. All right, how about this last one? I went from the black to the pink. I flipped it. So I'm going to use my fancy term for that, reflect. And we are only going to cover reflections in the x-axis. If you want more, take pre-calculus next year. You do more in pre-calc. Haley says yes. All right, let's look at this table. Because what I'm going to do is I'm going to give you an equation. And I'm not going to let you use Desmos. You just have to be able to look at the function and know what transformations have happened. So I look at my first one. Well, the 2 out front says I have a stretch. Stretch by 2. Should probably write down the amount. I then translated left 2, and I translated up 1. So let's take a look at these examples here and see if we can figure out what's going on. I have a negative sign out front. What does that tell me to do? I got to reflect in x-axis. Yes, I'll be nice and specific. What does the +4 inside the parenthesis tell me to do?
Go to the left 4.
Correct. Left 4. And then -3?
Down 3.
Down 3. All right, let's look at example 3 together.
If the 4 is positive, why would you go to the left?
It's the opposite of what you think. I know. That's why inside the parentheses versus outside the parentheses. I'm glad that you're making that connection. Because that's like the trickiest part of today. Is that difference right there. All right, in example 3, the -5 inside.
What would we do with the
Right 5, that's right. So translate. It's the opposite of what you think. It's a minus, but it has me go right.
But what would you do with the exponent?
So this is just, regardless of what function I'm looking at. I could put a 16 in there. It's still going to translate it from my parent function this way.
Okay.
I know. I was trying to show different examples in your notes. Up 7. So I went right 5, up 7. All right, look at example 4. There are 4 things going on. I don't care in what order you write down the transformations. It does not matter the order. Try to find at least 3 of them. The 3 transformations going, or there's 4 transformations going on. See if you can find at least the 3. see most pencils in the air. Okay. Shout out one transformation that's going on here.
Flip the x-axis.
Reflect x-axis. Got it. Another one.
Compress by 1/2.
All right, someone other than Brandy. That's okay, Max. It's all right. We're still learning.
Translate down 9.
Translate down 9. Yep. Thank you, Ian. And then last but not least, this -1 in the parentheses. Do I go right or do I go left? I go right. So that's going to be a big part of your homework, right? Is you're going to have to maybe write an equation that does these types of transformations. Right, couple more kind of like random examples that we can do together. We'll just do one of these. If I start with a function that has a domain of -3 to 2, not inclusive, and a range from 1 to 6, inclusive, that is translated left 2 units and down 4 units, what is the new domain and range? So here's where I don't give you a visual at all. I don't even tell you what the function looks like. This is a brain teaser. This one definitely makes us think. This is a sample type of ACT question, right? I don't have to provide you with a graph, just some multiple choice answers. When I move left and right, does that affect my x values or my y values?
X.
My x. So when I move left 2 units, that's going to affect my domain. When I move down 4 units, that is going to affect my range. Right? Up and down, that's going to affect your y values. So I look at the translate left 2 units. I started from -3 to 2. So I've got this function. It's going over -3 to 2, and then I shift it this way, 2 units.
-5 2.
Yes, I subtract 2 from both my start point and my end point. So I now have -5 to 0.
Oh, you subtract it from everything.
I have to subtract 2 from both my start and my stop, exactly, because I'm shifting the entire function over. Now for my range, since I'm going down 4,
-3 2.
I subtract 4 from both my start and my stop. So yes, I get -3 2. Because this one had brackets to start out, it ends with brackets. Because this one had parentheses to start, it ends with parentheses. You will see one question like that on your homework. That's why I wanted to make sure we went over them. Now the bulk of your homework, or at least the whole front page, is just drawn pictures. So that's why we did all that practice in Desmos, of drawing our pictures. I have this function here. We haven't studied this function. It's called an absolute value function. We will study it next. I need to go up 2 and to the right 3. So here's my recommendation. Pick 3 points. Any 3 points. 3 points, you're kind of covered, right? You're going to cover all your bases. Take each one of those points and move it up 2 and to the right 3. Up 2, right 3. Once you've done that, just redraw your function. In the case of this function, it started off as a V, so it needed to end up as a V. Any questions on that? All right, our last example of the day. I want to compress this graph by 1/2, so I'm going to push it from both the bottom and the top so it gets closer to the x-axis, and then I'm going to flip it. I'm going to reflect it over. So I've got 2 different things to do. Notice here, my highest y value is 3. So that's going to come down to like 1.5. So I kind of push it down. So it's at about 1.5 now. So I've done the first part. I compressed by 1/2. Now I need to reflect it over my x-axis. And like I said, that's a big part of your homework. So the final transformation is it ends up in the red there, where I've compressed it and then I've also reflected it. Good job today. I know that was a lot.